Hi, I'm an old guy and I do maths, and today we're looking at how we can use a stem and leaf plot to make a box plot, just to show the data in a different form. Now, the thing about stem and leaf plots is that they do contain all the data points that you need, but they are sorted conveniently into classes. Now, what is it that we need to make a box plot? Well, we need a 5-figure summary. And those 5 figures are the minimum, which we see here as 1. We read this as 0. We read the 0 rather as the start of the ones column, if you want to look at it that way, or the ones class. This we read as 13 and 14. So this we read as 1 and 2. So the minimum is 1. The maximum is 94. Those are the easy ones. Now, what we want to do is we want to find the median value here. And I don't know how many pieces of data I put in here, so I'll have to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so we are looking for a number between the 12th and 13th data point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just to check, coming back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our median value is 42 plus 43 divided by 2, which equals 42.5. So the median is 42.5. Okay, so now we have the data split into 2 pieces. Let's find Q1, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So we want to find the midpoint. 1, 2, 3, 4, 5, 6. We'll just pop a little tag there so that I know where that is, and we count backwards. 1, 2, 3, 4, 5, 6, and our midpoint is between those. So it is 26 plus 27. That's a 27 divided by 2, which is 26.5, and that is Q1, 26.5. Down here, we've got 12 pieces of data again. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6. There. Check again. 1, 2, 3, 4, 5, 6. Okay. You've seen me do this before. This is 78.5. So Q3 is 78.5. Now, that is our 5-figure summary. So, let's take that, and here's a number line conveniently drawn, and our bottom value is 1, and our top value is, get it on the same line, 94. Time to reach for a ruler, and this is just kind of approximate. We'll say that 26.5 is about there, and we'll say that 42 is about there, 42.5, and we'll say that 78.5 is about there, and we'll just join those up very quickly. This is very rough, and if you were doing this properly, you'd have a properly calibrated line here. But anyway, there's our box plot. Min, max, Q3, median, Q1. This is also Q2 if you need to know that. The values here are 26.5, 42.5, and 78.5. and that's that all done. It's a fairly simple process, but it can be done, and it's just another way of presenting the data. Now, here you have all the data points sorted into classes, as I said, and if you were to turn this rather 90 degrees, you could see whether this is skewed or whether it's sort of normally distributed. Down here, you can see the same thing, that there is no real evidence of skewing here. This isn't off, apart from my drawing, it's not off wildly to the right or the left. There are no long tails. But this gives us another way of looking at the data, and we can see, for instance, that 25% of the numbers are between 1 and 26, as it turns out. 26.5 is the median, and each one of these represents 25% of the numbers. And you can see from this, like you can see when you turn the stem and leaf plot by 90 degrees, you can see how this thing is distributed. Anyway, that is how you use a stem and leaf plot to make a box plot. There you are. Thank you very much for watching. I hope that was useful. If it was, please like and subscribe, and I'll see you next time. Bye.